Naming binary ionic compounds where cations have variable valencies. So this periodic table where common charges for ions are listed. Now, for anions, so far it's fairly straightforward. Every ion has a definite charge, and you can figure these out using the octet rule. For cations, however, it is not so simple. Now, some of these have to be learnt. You can't really predict them based on the octet rule. Most notably Ag plus and Zn2 plus, and so on. But more importantly, if you look here, there are some of these, like most notably in the D block. So for mercury, for these, so transition metals, and also for the heavier group 3 and 4 elements, what you find is that elements can have different ions with different charges. Now, in our naming scheme, we have to make sure that we name it in such a way that the charges are clearly indicated. And as a result, what we do is put the charge of the cation in Roman numerals in parentheses. So for example, if I wanted to name CuO, and I'll explain how we get to that in a minute, the copper charge is +2, so this is copper 2 oxide, whereas if I have Cu2O, then the copper charge is +1 only, so I get copper 1 oxide. In this course, you will not be required to know the older scheme of naming. One thing you have to be careful with, though, is the mercury 1 ion. And this is actually a polyatomic ion, but it's worth mentioning here that a mercury 1 ion is Hg2 plus. So 2 plus ion. So therefore, if I have mercury 1 chloride, then I would have Hg2Cl2. I can't break this down into HgCl because this Hg2 is a single unit. So how do I name these? The first thing I have to do is actually figure out the charge on these. So for example, here, the name here, okay, my oxide ion, I know it's -2, and I have 3 of those, so I have a total of -6 charge. So I need a +6 charge to balance out this -6 charge so that the compound is neutral. As a result, I have +6 charge and I spread it out over 2 atoms, so it's +3. So I must have a +3 charge here. Therefore, I have an iron 3, because this is +3, oxide. In contrast, if I have FeO, then this has a -2 charge, so this must have a +2 charge, so I have an iron 2 oxide in this case.